This screencast is for AP Chemistry in Chapter 19 with the Advanced Thermochemistry. We're going to focus on calculating the entropy changes for reactions. Just like H, when we did that in Chapter 5 in Honors Chem, we are going to find S in a similar way. The 0 in the air there is the standard molar entropy, is S0. If we had H0, it would be the standard molar enthalpy. So you will find these in the Appendix C, which is in the back of the book, and something like 1110, I think, is the page number. There are also a select numbers of entropy values on page 817 in your book. And the units that are listed are going to be joules per mole Kelvin, because it's molar entropy, so it's entropy per mole. And we are going to see these listed in joules. Be cautious. You will need to be aware if they're giving you values in kilojoules or joules. You may have to convert it. Just like enthalpy, you're going to find the change in entropy by taking the sum of the products minus the sum of the reactants. So we have an example here. Delta S, we're going to find the delta S0 for N2 plus 3H2 makes 2NH3. So if you were to go in the back of the book, you would find the NH3 value, which is, we're going to take 2 times that value, and it is, if you look it up, it's 192.5. And we're going to find that sum, and we're going to subtract it from our reactants. So if you look up N2, it is 191.5. And then our 3 times our H2 value, which is 130.6. So when you do that math, you multiply and you add and subtract, you're going to get a delta S0 value of negative 198.3 joules per mole Kelvin. Now, you will find you remember this process, so this is not a challenging topic in order to solve. Couple of observations about entropy. When we did enthalpy, which is H, some of the values when they were in their elemental state were 0. Entropy does not have any elements listed as a 0 value, so you can't just assume that. You will have to look up the values for any elements and any compounds in your thermochemical data table. Entropy values, or molar entropy values, for gases are going to be bigger than liquids, which are both bigger than solids. And that makes sense because gases have more disorder than liquids, and both gases and liquids are more disorganized than solids. Entropy values are going to be bigger when you have a bigger molar mass in general. So if you look at a compound that has a higher molar mass, you may be able to explain why the entropy is bigger or smaller. Okay, looking at the molar mass. And then entropy will also tend to increase with the number of atoms in the formula. Just like molar mass would increase with the number of atoms, you also can say that if you have 5 atoms versus 2, the entropy would be bigger for the substance with the 5 atoms.